Okay, today we're going to be talking about rational expressions and inequalities. So this has been giving people fits. So I want you to keep in mind what we're about to do. It's going to sound very simple, and it takes a little time. It is complex in how we actually go about doing it. But we're going to solve as if it's an equal sign, and then we're going to plot our solution and our excluded values on a graph and test sections of the graph to see where our shading lies. Okay? So we're going to solve first. When I look at this, I need to get a common denominator. When I look at 3a, 4a, and 6, 12a is what I want to get, which means the first one gets multiplied by 4, second one by 3, and the last one by 2a. Very basic. This is not the new skill, which means we're left with 20 over 12a minus 9 over 12a. And again, I'm going to treat it like an equal sign, okay, for right now. And we're going to get 10a over 12a. All right, we have the same denominators, but it is important. Look, what is my excluded value? 0. That would make a denominator 0 here. I look at the tops now. 20 minus 9 equals 10a. 11 equals 10a. So a equals, I'm going to make it 1 and 1/10. So we're done solving, but now we need to go about graphing, and I call this first one my scrap graph. I'm not going to have my final answer on it, but it is going to help me find my final answer. Make a number line. 0 and 1 and 1/10. Now, I do want to point out that the inequality here is not equal to, so that's why I have an open circle at 1 and 1/10. And the excluded value is what you're not allowed to be, which is, again, why it's an open circle on my graph. Now, you notice that it cuts the graph into 3 sections, 3 different sections. So I'm going to have to test points in all 3 regions. The region left of 0, I'm going to select -1 as my x value. In between, it's kind of easy pick. I'm going to pick 1. And to the right, I'm going to pick 2. This is why we don't really like this. This takes time. We have to plug these values back into our original and see if it makes a true or false statement. If it makes a true statement, we have shading there. If it makes a false statement, we do not, and it will not be a part of my answer. So, time to just get to work. If I test where x equals -1, means I go to my original. 5 over. I'm going to do some mental math. I plug -1 in for a. I get a -3. Minus 3 over, mental math, we get a -4 is greater than 5/6. I need to see if that makes a true statement, okay? So I have a -5/3. I'm going to end up adding 3/4, and I need to see if that's greater than 5/6. Now, let me be very, very frank. I want you to be intelligently lazy about this. Don't do more work than you have to, because we're just seeing if it's true or false. Look at what we have here. Does everyone understand that this is larger than 1? Right? This is a larger than 1 negative number. So when we take away 3/4, do you understand my result here is still going to be negative? I'm just using logic right now. The result here, because that's a larger negative number, is going to be a negative number claiming to be greater than 5/6. I can stop here because all I want to know if it's true or false. I can see at this step, this is going to be false. If not, get common denominators and continue. You'll find out I'm right, all right? But as soon as you can tell whether it's true or false, stop. I saw right here, this is going to be a false statement. So I know I won't have shading there. Move on to my next point. Now I'm going to test 1. So I go back. I plug 1 in. I get a 5 over 3 minus 3 over 4. Notice that it's 3 and 4 because we just multiplied by 1. Greater than 5/6. Now, this is what we're going to have to do some work on. So what I recommend doing, the same way we get common denominators to see them all at the same, well, let's do that. It's still going to be 12. So I'm going to have 20/12 minus 9/12 greater than 10/12. leaves me with 11/12 greater than 10/12. Hey, that is a true statement. That is a true statement. So yes, I will be shading there. I will be shading. Last section. I got a test where it's 2. I have to check all these sections to make sure I know what shading will occur. So I have 5/6 minus 3/8 greater than 5/6. Can you guys still see that? Okay. Notice again, all I did was plug 2 in to both of these. Logic. Use logic. Watch. You see how you have 5/6 on both sides? But on this side, you're taking something away from the 5/6. So clearly this left side is going to be less than 5/6. Does that make sense? I hope it does. Taking away from 5/6 will clearly make it smaller. Then this has to be a false statement. There's no way you take something away from 5/6 and it be greater than 5/6. So at this step, I know this is also not true. And again, if that doesn't make sense to you, you continue going. LCM here would be 24. Continue down and get that statement that makes sense to you. All right, now I told you again, this is my scrap graph. I use this graph to help me decide where my answer will lie. It's time for my graph. My final answer on my graph. My shading only exists between 0 and 1 1/10. Open circle at 0. Open circle at 1 1/10 with shading in between. Lastly, interval notation, least answer to largest answer, 0 to 1 1/10, parentheses because it is not equal to. Now this is a fairly simple example. I know that we have had some where you have to factor. The key here is, after you solve and you have your excluded values, you plot all of those on a number line. However many sections of the graph there are, you have to test a point in each section to see if it's true or false. If it is true, it will represent shading in your final answer. If it is false, it will not. And then once you see your shading, you write your interval notation based upon your shading on your graph. Hopefully that helps. Quick tutorial on how to use rational inequalities.